Welcome back. Today I would like to share a little about covalent compounds. And if you know anything about covalent compounds, you know what I'm talking about. Before we start, let's do a quick review over the bonds that we've already gone over. We've talked about ionic bonds. Remember that ionic bonds are between metals and nonmetals. Possibly they could also be between metals and polyatomic ions. Remember, a polyatomic is the groups of atoms that have an overall charge. Those darn ones that you have to memorize. Sad face. Anyways, in these bonds, electrons are transferred. They go to the more electronegative atom. Remember that electronegativity is an atom's ability to attract electrons. So the more electronegative one is actually going to steal those electrons from the less electronegative one. Then, once those electrons are transferred, you have some charges. You've created those ions, and there's an attraction between those charges. The second type of bond we talked about is a metallic bond. These were like the alloys when we made the gold pennies, between a metal and a metal. And this is because we have that sea of electrons. These are the very mellow atoms that don't really steal, they don't really share, they're just kind of hanging out and their electrons are just there. And remember, those alloys are the mixtures of metals that have those different properties. So we've had bonds with metal and a nonmetal, a metal and a metal. Take a guess about what a covalent bond is? If you said a nonmetal nonmetal, you are correct. We are looking at this side of the periodic table. Remember that we have our staircase here that separates our metals and our nonmetals. So if we have two elements from this side of the periodic table, it'll be a covalent bond. Now we know that all those elements on that side of the periodic table want electrons. They are really close to becoming noble, so they're not going to give any up. That means if everybody wants some, they're going to have to share. And these compounds, kids find these a little bit easier than all the rest because they can combine in a lot of different combinations and you can't predict them. That means I have to tell you what it is and all you have to do is name it. So for example, we have carbon can form with oxygen in CO, CO2, you've seen it form in CO3 in your carbonate polyatomic ion, so there's lots of different ways. Here we have nitrogen combining with oxygen, NO, NO2, N2O, these are all known as NOx compounds. Obviously, lots of different combinations that can occur, and we really don't predict how those come together. So, our covalent bonds are bonds formed by the sharing of electrons because they both want electrons. So they have to get along, they have to play nice, and share. What this kind of looks like is they each keep their electrons, but just in the middle is where they're going to bond eventually. They come together and they share those electrons so that both can have some part of an electron to make their octet. So since we can't really predict those covalent compounds, all we have to do is name them. So here are your naming rules for covalent compounds. The first part is to name each element with a prefix telling how many there are. So if there's only one of them, you would use mono, unless it's the first element. Then we just assume one if there's one. 2 is di, 3 tri, 4 tetra, penta, hexa, hepta, octa, nona, deca. You've probably heard a lot of these before, like a tricycle, or a pentagram, or an octopus, or an octet. 8 means oct. The second part here is to name the second element with the prefix and put in an "-ide" ending. So this is very similar to how we were naming the ionic compounds with the IDE at the end. So let's try a few of those. Remember, the key thing to keep in mind is do not add mono to the first element if there's only one. So let's look at one that's probably fairly familiar to you. CO2. We have one carbon. It's our first one, so we don't add mono. We're just going to name it. So carbon, and we have 2 oxygens. So our prefix for 2 is di. We name our second element with an "-ide" at the end, carbon dioxide. Let's try another one. CO. Some of you might be familiar with this one as well, Hopefully not too familiar because it's not very good for you. But again, we have one carbon, so we would name just the element because we don't use mono with the first. So carbon, and we have one oxygen as our second element. We do use mono with the second. So carbon monoxide. Don't worry about the spelling. I won't count off or anything. This one's kind of tricky because you don't say monoxide, it's just monoxide. It's just easier that way apparently. All right, one more here. Nitrogen and fluorine have bonded. We have one nitrogen. So again, do not name the nitrogen first, or do not put a mono on your nitrogen. But we have nitrogen, and then we have 4 fluorines. So the prefix for 4 is tetra, and we have fluorine with an ide is fluoride. And our last one, N2O3. So this one's a little different because now we have 2 nitrogens to start out with. We only don't use the mono, but we do use the other prefixes. So we need a di in front of this because we have 2 nitrogens, so dinitrogen. And we have 3 oxygens. Remember the prefix for 3, like that tricycle you used to ride when you were little, is trioxide. Okay, so in each of these we ended with the ide. We put a prefix in front of each of them unless it was 1 in the first element. And it's as easy as that. We will see you in class.